Everyone, welcome back to another fun and exciting Algebra 1 class. Today we'll be in Chapter 10, Lesson 7. I think I'm going to combine Lessons 7 and 8 right here because really these two lessons go together, and I think that I can teach it in about 15 or 20 minutes, both together, okay? So you'll have to put your seatbelts on. Get ready. I might talk a little faster than normal, but I'm going to try to do two for the price of one. All right, so let's talk about this. Chapter number 10, lesson 7. This is on page 379. Scatterplots. What in the world is a scatterplot? Man, some of these things I've never heard of. Mr. Steve, I never heard of a box and whisker. What's a scatterplot? Well, it sounds like what it is. Scatter means things are just all over the place. They're scattered all over the place. And to plot is to put a point on a map. So scattered, they're just points that are scattered all over the place, okay? Not necessarily just in random orders, but the numbers, the data make it so that these plots, these points are scattered all over the place. All right, let's talk about those dots. Let's talk about those data points. Look down here at the screen. Univariate and bivariate. Univariate is single data, okay? Uni is 1, okay? Bi is 2. So single variable data. In other words, that would be like an X only. They only have one value, okay? So these are a lot of the basic ones that we've been doing, like the bar graph and the circle graph. You're just dealing with one data, one variable, okay? So it's how many, Shakespeare plays. That was only one variable. It was only one thing that we were worried about, okay? What was the weight of the football players? Some of the different things that we've been talking about in these examples. Univariate, okay? It's only one variable. Now, in this lesson, we're going to be talking about what's called bivariate data. In other words, there's two different variables that are influencing the graphing and influencing the data points that are coming in. All right, notice down here it says sometimes there are other variables that have an effect on the data. So there's something else that's pulling the data one way or the other, okay? For example, the hotter the temperature outside, the more ice cream you will sell. Now, I don't know about you, but I love ice cream. I love ice cream. It's one of my favorite things in the whole world, okay? So when it gets hot outside, better look out because I'm stopping at Dairy Queen every chance I get. I'm stopping at McDonald's for an ice cream cone. Whatever I got to do to get me some ice cream cone when it gets hot outside. I love me some ice cream cones. Now, maybe you're the same way. You love ice cream. The hotter it gets, the more of a desire you have for it. Typically in the wintertime or when it's cold, you're not thinking, boy, I'd love to get some ice cream. Maybe I love it all the time, but more so when it's hot outside. What is the second effect? The first effect is my desire to eat ice cream. I love eating ice cream, so I'm going to want to eat it no matter what. But the second variable is the hotter it gets, the more I want to eat it, okay? So the colder it gets, the less I would want to eat it. In other words, the temperature is affecting my desire to eat ice cream. That's what's called bivariate. All right, let's look down here. I have a little graphic here. The temperature outside in Fahrenheit degrees, 85, 88, 91, and so on. And that is related to cups sold. We're going to sell some lemonade today, and we're going to use that same idea that the hotter it gets outside, the more lemonade people want to buy, the thirstier they are, because the heat is making them desire more water, more lemonade, and so they're more willing to buy it the hotter it gets. So there's two different variables. The first variable is the temperature. The temperature is the independent variable. We can't control that, okay? It just does its own thing. The cups of lemonade is the dependent variable. In other words, it depends on what the other person. In just a few lessons, we're going to start talking, actually in chapter 12, I think, we're going to start talking about direct variation. And this is a direct variation problem. In other words, here's what's happening. The temperature is directly affecting the amount of cups that are being sold. So when it goes down, the amount of cups that we sell goes down. When it goes up, the amount of cups that we sell goes up. So the cups are the dependent. It depends on the heat outside. The temperature is independent because we can't control that. It just is what it is. Okay? All right, so cups of lemonade sold. Here's what we're going to do. Here's our little plot. Here's our little graph. We're going to take, and in that yellow color, we're going to put everywhere that there's a data point, we're going to put it on there with this yellow color. So let's do this first one first. 85 degrees, we sell 56 cups. So we're looking for 85 degrees. So it's going to be somewhere right in here between those two. And how many cups do we sell? We sell 56. So somewhere right in there, we are going to put a point, a plot, a dot. When it's 88 degrees, we sold 69. Now it's 88 degrees and 69. So up to 88 and 69, somewhere right in there. Going back, 91, we sell 80. So 91 degrees right here, we sell 80. You can see it right now. You can already see it kind of going up, right? Well, let's keep plotting because we have more things to put on. 92, it's 78. So this is an interesting one. All right, one thing to notice here, and we'll talk about it just a little bit more in the future, there are other variables here. Maybe they were selling lemonade on a Saturday here and on a Monday here. So more lemonade sold because it was the weekend. There's always more variables in play than just two. This scatter plot is focused on two of them, but there are other things involved here. Maybe one day they had somebody different selling the lemonade, and so they were not as good of a lemonade salesman. There's a number of different things that can happen to make different numbers go down and up. The traffic on the road, maybe there was an accident that slowed down traffic, and so there were not as many people passing by their stand, or who knows what it was, okay? But there are always more variables influencing this than just one. So then the next day is 90 and 69, so 90, and we sold 69 that day, so right about there. And then 87 and 60. 87 and 60, 90 and 67. Next one is 91 and 79. One right about on top of the other one. And 93 and 81. And the last one is 89 and 70. So 89 and 70, right about there. Now, if you'll look at this scatter plot, and this is why I want to tie the two things together. Right now, all we did was scattered points all over the place. But one thing that you've probably noticed is that you're seeing a line forming here. And it's somewhat of a straight line, or it can be a straight line. Let me make it a straight line. So we can kind of make that a straight line, right? And some points would be on one side of it, some points would be on the other, but we can kind of draw a straight line up there. All right, this line of fit is the next lesson, lesson 10.8, and it is on page number 385. So if you look, they even tie the two together. The graphic that you're looking at on page 385, the first one, is cups of lemonade sold. All they did is exactly what I did. They took and they drew a pink line into it, and they connected the bottom to the top. Okay? Now, let's talk about that line of fit. That line of fit does something for us. Look right here. The ultimate purpose for studying this data is to make projections for the future or the past. If you're concerned about what happened in the past, maybe, and you don't have the data, you can draw, like we could continue drawing this line down, okay, for when it got cold outside. We don't know what it's like when it gets cold outside, but for instance, if it's less than 84 degrees, the colder it gets, we can keep going this direction, and the line should hold true. Now, again, other things affect it based on, just the desire to eat ice cream in the winter. People want to eat it in the winter too, even though it's cold. So the line is not going to be perfect all the way down. And the other thing is we can't really keep going up with this because at a certain point, it doesn't get more than 100 degrees outside very much. And so at some point, you're not going to sell 1 million cups of lemonade because you're on the face of the sun. Nobody can live on the face of the sun. So there are other things that come into effect here. So there's limits that are on these, but I just want to talk about this basic fit line right here, kind of the one that's on our graph. So go over there to page 365 and just kind of look at it with me, and let's talk about some things. Fit line is a line that indicates the relationship between those two variables. We can extend it in both directions, but the farther you get away from the data, so where is our data? Our data all fell between 84 degrees and 94 degrees. So the farther we get outside of that data, like if we tried to let me throw a word at you. It's called extrapolate. If we tried to extrapolate this data all the way down to 30 degrees, it would be very inaccurate. Why? Because we're so far away from our data point of 84 degrees. If we tried to extrapolate it up to 120 degrees, it would be very inaccurate because we're getting so far away from our 94 degrees. And there's so many other factors. Nobody lives where it's 120 degrees unless, they're just strange. Or they live in Phoenix, Arizona. Sometimes it gets hot out there. But I bet you they sell a lot of lemonade when it's 120 degrees. Okay? The next thing. And I'm almost done. The fit line always have more than two variables influencing, and that's what I talked about earlier. So it is impossible to make 100% accurate projections about the future or past events. We can make some projections, and like I said, the closer we get to the data, the more accurate our projections can be. All right, so let's make a projection about our data that's not on here. Okay, so look at this. This right here, let me change that color. This right here, 94 degrees. We don't have any data from 94 degrees, okay? It stops at 93, okay? So let's make a projection at 94. How are we going to do that? Well, the book is going to give you that equation. In later on in trigonometry and in physics and in different places, you're going to learn how to build these equations. But for right now, Algebra 1, they're going to give you the equation. Here's what we want to do. All we want to do is plug in our temperature. What's the temperature we want to know about? This is what's called extrapolation. We want to extrapolate 94 degrees. Okay? So what's going to happen if we try to extrapolate for 94 degrees? Well, let's plug it in. Okay, real quick before we do that, let me tell you about this word that I'm using, extrapolate. To extrapolate is to get something that's outside of the range of the data, so outside of our points right here, okay? So if I want 94, it's outside of the range. I need to extrapolate. Let's say that I wanted one of these, like 86 doesn't have a point on it, but 86 is inside of our range, okay? So our range is from 84 to 93. So 86 is inside of that. That's called interpolate. If it's inside the range, we're interpolating. If it's outside of the range, which was what we're doing for 94, it's extrapolating. But the process is the same, okay? They call it different things in math, but the process is the same. So here we are. We're going through the process. Here is our fit line. Remember what a line looks like? Y equals mx plus b. Guess what we have right here? We have a line. There's our m, here's our x, and here's our b. Okay? This is a line. So let's go ahead and plug into it. 3.3 times 94 minus 225.9. You say, where did we get those numbers? The book gave them to us, okay? Like I said, we're not ready for that yet. We're not ready to build this equation yet. Soon, in a few years, you'll be ready to build this equation, but right now, we're not quite there yet. Okay, so what we want to do is go over here to our calculator, and we're going to do this 3.3 times 94. 3.3 times 94 equals 310. Okay, so we want to take this 310.2, and we want to subtract 225.9. And that is going to equal 84.3. And our y is our cups. So y equals, or cups. So our cups is going to equal that 84.3. 84.3. So let's go back up to our graph, and we would have on this, we would have 84.3 somewhere in there. Okay, so we're right there, right near our line. Our line looks good, and our point fit really close to our line. Okay, and that's the way it works. That's the way fit lines work, and that's the way scatter plots work. And you just plug your data in. They'll give you your formula, plug your information into your formula, and you can extrapolate for things that are outside the range, and you can interpolate for things that are inside the range. All right, that's all I got for you in this lesson. Hope you learned something. If you didn't, slide it back and watch it again. We'll see you later. Have a good one. Bye-bye.